statement that the volume occupied by a fixed amount of gas is directly proportional to its absolute temperature, if the pressure remains constant. This empirical relation was first suggested by the French physicist Jacques-Alexandre César Charles about 1787, and was later placed on a sound empirical footing by the chemist Joseph-Louis Gay-Lussac. It is a special case of the general gas law and can be derived from the kinetic theory of gases under the assumption of a perfect ideal gas. Measurements show that at constant pressure the thermal expansion of real gases at sufficiently low pressure and high temperature conforms closely to Charles' law.
Hi everyone! My name is Kurt Justin M. Santos, and I am from Grade 10 Rutherford, Infant Jesus Montessori Center, Laguna.
Do you know Jacques-Alexandre Charles? He was a French inventor, scientist, and a mathematician. He made an experiment about gas law that described how gases tend to expand when heated.
So now, let's do this experiment. So first, we have blow up this balloon.
Oops, safety first. Use gloves and goggles for safety. Second step, we need to place this balloon into the boiling water. So, as the temperature increases, the volume of the balloon increases.
So the next step, we must place this balloon into the cold water.
Wait until the balloon decreases its volume. So, as the temperature decreases, the volume of the balloon decreases. And that is Charles' law. Thank you and goodbye.
Solving for final temperature. A gas in a container has an initial volume of 2 liters and an initial temperature of 25 degrees Celsius. The final volume decreases to 0.25 liter. What is the final temperature? The first thing I'm going to do here is write out my formula. V1 over T1 is equal to V2 over T2. The second thing that I'm going to do here before I plug any number into my formula is convert 25 degrees Celsius into Kelvin. So that's going to be plus 273, which gives me 298 Kelvin. Then I'm going to go back to my problem and plug in my variables. A gas in a container has an initial volume of 2 liters. So my V1 is 2 liter. An initial temperature of 25 degrees Celsius, so that is 298 Kelvin. The final volume is decreases to 0.25 liters, so 0.25 liters. What is the final temperature? So we are solving for T2. So I'm going to cross multiply here. The first thing I'm going to do is cross multiply. When I cross multiply, acknowledging that units are there but just for the sake of space, it's going to be 298 times 0.25 is equal to 2 times T2. 298 times 0.25 is equal to 74.5 is equal to T2 times 2. I'm going to divide both sides by 2. In my temperature, my final temperature is found to 37.25 Kelvin. And I could start there with my Kelvin temperature. If I had to find degrees Celsius, I would subtract 273 from this Kelvin. Temperature and my final temperature in degrees Celsius will be negative 235.75 degrees Celsius.
Charles' laws application to problem solving. In this video, short video just talk on how to apply our Charles' mathematical equation of inverse relationship of pressure and volume and temperature. We know that V1 T2 is equal to V2 T1. That is mathematical expression of your direct relationship of volume and temperature. So let's apply to that particular equation to this problem here. You have a 600 ml sample of nitrogen gas that's heated from 27 degrees Celsius to 77 degrees Celsius of constant pressure. And of course, that constant amount, what is this final volume? So again, in every expression, you have to segregate final. At 600 ml, that is considered to be your V1, 600 ml of sample, and you heat it from 27 degrees to 77 degrees. So 27 is your initial temperature. You convert it in this given. So the plus 273 is Kelvin. So this will become sum in is 300 point is Kelvin. So this final Kelvin temperature that we will be using. And 77 degree is your T2. So 77 degrees Celsius, we have to add 273 to 15, so that we can get the Kelvin, which is 350. 350 point is 15 Kelvin. Ready to solve for the final wall for V2. So to solve for V2, we need to get rid of T1. That means that final equation that we will use for this is V2 is equal to V1 T2 over T1, because we need to divide both sides by your T1 so that you can remove the correct. So now we're ready to substitute our units are okay. So that is 600 ml times 2, which is 350 point is 15 Kelvin over 300 Kelvin. T1 point is 15 Kelvin. So putting that in calculator and putting everything, you will get 699.95 So this become our final answer. This is 9.95 m, and this becomes our final answer. This is 6 of nitrogen gas, so have to put the substance so that a final volume of your nitrogen.